Okay, so welcome back once again to our discussion and the tutorial on binary addition and binary subtraction. So in today's module, let us have a look at the topic called as multi-bit binary subtraction. So in the previous model, we talked about binary addition, the multi-bit binary addition, and this time we would explore the topic of multi-bit binary subtraction. So to begin with, here are some basic rules in binary subtractions. So there are four possible combinations of doing a binary subtraction. You have logic 0 and you have logic 1, and therefore you can see that when you want to subtract 0 from 0, so the first bit here is called as minus, and the second bit is called as subtract, and this is the difference, that is the output here. So 0 minus 0, the difference is 0. 1 minus 0, the difference is 1. When you want to subtract 1 from 1, that is 1 minus 1, the difference is 0. And finally, if you want to subtract 1 from 0, obviously 0 is less than 1. So in binary, this is treated as 0 has to borrow 1 from another bit, then only it will allow this subtraction to take place. So 0, when it borrows 1, as we will see ahead, it becomes 1 0 in binary. 1 0 in binary is 2 in decimal. So we read it as if 2 minus 1 is equal to 1. So in binary, it is 0 minus 1, that is 1 0 minus 1, that is equal to 1. Let us understand the same in the tabular form. So you have bit A, it could be logic 0 or 1. You have bit B, it could be logic 0 or 1. And therefore, these are the two bits, two numbers, each having one bits, 0 or 1. There are 2 to the power 4. 2 to the power 2 equals to 4 possible input combinations starting from 0 0, 0 1, 1 0, and 1 1. Obviously, there are two outputs called as difference and the borrow. So when you have a 0 minus 0, A minus B, 0 minus 0, the difference is 0, and it doesn't have to borrow from another bit. Therefore, the borrow out here is equal to 0. So this is the first combination what we wrote here. If you go for 0 minus 1, A minus B, we are doing here. So 0 minus 1 is this combination. So now you see the difference is 1, what we saw here, and it has to borrow 1 from another position, another bit. So 0 has to borrow 1 from the another bit. So we'll see that how it borrows that 1. So therefore we say the borrow out and the borrow in both uh, places is equal to 1. So borrow out is 1, and because it has borrowed 1, right? Therefore the output is borrow out is equal to 1. Here you have 1 0, A minus B, so difference is 1. Obviously, to subtract 0 from 1, 1 is bigger here, greater. You don't have to borrow. A doesn't have to borrow any 1 from the another bit. Therefore, the difference is 1, but the borrow is 0. It doesn't have to borrow out anything. Borrow out is 0. Finally, 1 1. Obviously, both are equal in numbers. The difference is 0, and the borrow is 0 because A did not borrow any bit from another bit. We'll see how it goes in terms of the example. So this is called as borrow method. For example, you have to subtract 1 from 0, and 0 is smaller than 1. So 0 has to borrow 1 from some another bit. Therefore, that becomes 1 0 in binary. In decimal, we will read it as 2 equivalent. So 2 minus 1, therefore equals to 1. So since it 0 had to borrow 1, we call it as a borrow method of binary subtraction. Let us understand this by means of an example. Let's say you have this word size of 4 bits. This is number A, 1 1 0 0. Now in decimal example exercise for you, tell me what is the decimal equivalent of 1100. Okay. Now second number B, again it's of 4 bits. It is 0010. So that is decimal equivalent here is 2. Tell me the decimal equivalent of 1100. So you see that there are 4 bits. This bit that is from in number A and number B, starting from the leftmost is LSB. This bit is most significant bit in number A and number B, that is MSB. So subtraction starts from least significant bit and moving from column to column, from left to right, one by one to the MSB most significant bit, that is the rightmost bit. So we'll start the subtraction bit by bit. So 0 minus 0. So go for the table A minus B, 0 minus 0. The difference is 0. And since the numbers are equal in magnitude, this number A this number A bit doesn't have to borrow from the next bit. So borrow out and borrow in here is 0. Second bit. We move to the next column. Now you have to subtract number 1, that is the bit 1 of number B, from bit 0 of number A. 0 is smaller than 1, or in other words, 1 is greater than 0. You cannot subtract this one. So this 0 will ask for a borrow from its next bit towards its right. Okay. So this 1 comes here. Therefore, 0 was already there. It becomes now binary 10. Binary 10 in decimal is 2. So we can see this subtraction as if you are subtracting this 1 from the 2 in decimal. So that is 2 minus 1, difference is 1. In another word, we'll see binary 0 minus 1 subtraction is as if you are subtracting 1 0 and minus 1. So it becomes 1. Now, there is this 1 came over here. So it borrowed this bit borrowed 1 to the left bit here, therefore it becomes 0. So now A has bit 0, B has bit 0, 0 minus 0, the difference is 0. Of course, this time to make this subtraction at this bit position, you did not borrow anything from here. So 1 remains as if it was there, 0 remains as it is, 1 minus 0 becomes, the difference is 1, against the borrow is 0 here. So this is the borrow method in the form of rules, in the form of table, in the form of example. There is one more way we can understand how this subtraction is taking place by means of some tabular representation. So to understand that, let's have an example of this borrow method. Let's say you have these 5-bit numbers. Number A, in decimal it is 24. You have number B, again 5 bits. In decimal it is 7. Obviously, if you do the decimal subtraction, the difference is 24 minus 7 is 17 in decimal. And we need to now write a binary equivalent of number 17. So how do we do that? And how you do the subtraction, you can see this by means of the example. So bit position, that is the first column. You have 5 bits starting from least significant bit and to the most significant bit. So you have two numbers A and B. So bit positions are AI and BI. So you see here number A has 5 bits, number B has 5 bits. So this is A0 A1, A2, A3, and A4. Similarly, this is B0, B1, B2, B3, and B4. That is how we started from LSB in the column here, and column here we started for number B. So number A is 00011. So we are reading here 00011 from LSB to MSB. Similarly, for the B, we are reading 11100 from LSB to MSB. We are reading 11100. Now you have to have third column, which is of borrowing. So we'll see now how these numbers are coming. So we do the first bit subtractance starting from LSB. We are subtracting B0 from A0. So 0 minus 1. Of course, B0 is greater than A0. You cannot directly subtract. So this A0 has to borrow 1 from the next position. Obviously, this 0 doesn't have anything to borrow here. So this has to borrow from this bit. And of course, this has to borrow from this bit. So we'll see that. So initial borrow is 0 here. So we see that 0 minus 1 minus 0. That's why we write it in this column. 0 minus 1 minus 0. The difference is minus 1. So you are basically making the subtraction 0 minus 1. The difference is minus 1. That is seen as you have a difference of minus 1. It means you needed to borrow 1. That's why it is a minus 1. So you can see that you borrowed 1, and therefore A naught became A0, 10. 10 in binary is decimal 2, and therefore 2 minus 1 is equal to 1. So difference here we wrote 1, and it had this addition of bit at this position had to borrow 1. That's what we write 1 is the borrow out. Same next bit, we are subtracting again 0 minus 1. 0 minus 1. Now you have borrowed 1 to do that, right? So I've just said that from the next bit you have to borrow 1. So you borrowed 1, you put in here, then you read this subtraction as 0 minus 1 minus 1, 0 minus 1 minus 1. So this is basically a minus 2. Okay, and you have borrowed 1, that's why it is in binary 10. In decimal, you are reading it, interpreting it as a plus 2. So minus 2 plus 2, their difference is 0. So difference here is 0, and you had borrowed in this step. From the next bit, you had borrowed 1. That's why borrow out is 1. Next bit, 0 minus 1. Again, you see in the table 0 minus 1. Here also you had to borrow 1 from the next bit. So you've said that borrow in comes here, that is 1, and you write 0 minus 1 minus 1. So here it is 0 minus 1 minus 1, that is minus 2. Of course, since you borrowed 1 from the next bit, this is as if 10, in decimal it is plus 2. And the final difference is minus 2 plus 2 is equal to 0. In decimal, we are reading like this. And difference therefore is written in this column 0. And you had borrow, and therefore borrow out is 1 here. Now that borrow out becomes borrow in for the next position. Now next bits are 1 minus 0. Here look, 1 minus 0. So you simply write it as 1 minus 0 minus 1. Right here, 1 minus 0 minus 1. This difference is nothing but 0. So at this position, you see, you don't need to write anything right here. So you see that simple difference, 1 minus 0 is 1. Again, 1 minus 1 is 0. So sum is, the difference is 0, and borrow out is also 0. Final bit, that is MSB. The two bits are A4, 1, B4, 1, 1 minus 0. And borrow in here 0, because the borrow out from the previous was 0. So it is 1 minus 0 minus 0 equal to 1. The difference is 1. Borrow out is 0. To read this, your final result will be, the difference here will be 1, 0, 0, 0, 1. Starting from MSB to LSB that you can write here, which is nothing but decimal 17. So let us say in a multi-bit binary subtraction, you have number A starting with the LSB, that is A naught, and going to the MSB, that is AN. You have number B starting with B naught and going to the MSB BN. And this is how we will read this number A minus B, that is you are subtracting B from A. So there are two outputs of this subtraction. Those outputs are called as sum, starting with S naught to Sn. S0 is your LSB and S naught is your MSB. Similarly, there is a borrow output starting from LSB B naught and MSB Bn. So we'll see how this takes place by an example. Let's say you have 8-bit number A0 to A7. There are total 8 bits. So the word size of number A is 8 bits. So you see that the number is LSB is 0, MSB is 0. And its decimal equivalent is 42. You have another bit B0 to B7, a word size of 8 bits, number B, and it is the bit positions. LSB is 1 here, MSB is 1 here, and its decimal equivalent is 233. And what you need to do is subtract B from A. Therefore, you will say that the subtraction in decimal is 42 minus 233. We want to do that. In decimal, it is easy to perform this decimal subtraction of decimal numbers, which will be result will be negative. We know that. But in binary, we'll see how this subtraction will take place. So you put this number A, that is 42. In binary, it is the bit positions as shown. Then you have number B, which is in decimal 233, and the binary representation is shown here. So you are subtracting B minus A, B from A. And the difference is you first start with the LSB, 0 minus 1. Obviously, 1 is greater than 0. The 0 has to borrow 1 from its next bit, that is right from here. So what you see here, we will write it here. So first, we see that it will borrow this 1 from the next bit, and therefore this 0 will become 1 0. In decimal, it is 2. So 2 minus 1 will be the 1 will be the difference output that we will write here. So here is the difference. Now, you see that the borrow that you borrowed from the next bit from here, you put the borrow here. Therefore, this you can read it as if 1 minus 1 now. So it is now 1 minus 0 is equal to 1, and 1 minus 1, the difference is 0. And again, in this at this bit position, to do this subtraction, you did not borrow anything. So the borrow in here is 0. Now at this position, the difference would be simply 0 minus 0 minus 0. So the difference is 0. You did not borrow any bit from the next position. So you again say that the borrow in here is 0. So here you subtract this bit of A, this bit of B, and this borrow in. So 1 minus 1 is 0, and 0 minus 0 again 0. And next bit, you did not borrow anything, so borrow in here is 0. Again, 0 minus 0 minus 0, the difference is 0, and the borrow out is 0, which is the borrow in here. So 1 minus 1 is 0, and 0 minus 0, the difference is 0. Again, you did not take any borrow from this position, so borrow out of this subtraction at this bit is 0, which becomes borrow in here. So now 0 minus 1, you have to borrow something from the next bit. right? So this bit has to borrow 1 here. Then only you will do this subtraction. Here, your difference is 1 because you borrowed 1 from this. Obviously, this bit doesn't have anything to borrow here. So it will look for from to its next bit to have a borrow, right? And but we'll see that the borrow came here, that became 1 0 in binary, and in decimal it is 2. So 2 minus 1 we wrote, difference is 1, and of course the borrow out is 1 here. So borrow out 1 we wrote here. But now you see that this also had to borrow 1. So we'll see that the difference here, 1 minus 1 actually is 0, and the borrow that this 0 had borrowed from somewhere can be, this is called as underflow. This one final borrow out is called as underflow. So what you see here, this is a negative number. The difference is negative 191 decimal. So you see that to represent 191, we need total of 9 bits as in the difference output. So this 1 at the MSB is indicating a sign, and remaining 8 bits indicating the magnitude of 191. So this is signed binary number which required us 9 bits to represent that. Okay. So that is how we did that. Let us say we swap the numbers and instead we now subtract 42 from 233. So again, see, we arrange these two numbers A and B, 8 bits each, and we start one by one. So how we do that? We start with the LSB, least significant bit. We try to subtract number B from A bit by bit. So let us start with the first LSB. That's 1 minus 0. And of course, there is no initial borrow in here. That is 0. Borrowing here is 0 because you did not borrow anything to do this subtraction at this bit. The difference is 1 minus 0 is 1. And here the borrow out is 0, which becomes borrow in here. So borrow in here is 0 at this bit. So 0 minus 1. Of course, now you have to borrow 1 from its next bit position because 1 here is greater than 0 and you cannot subtract. So now we'll see that this 0 borrowed 1 from the next bit position. We'll see whether where it becomes how it borrows 1 from its bit position. But when this 0 borrows 1, it becomes 1 0 in binary, which is 2 in decimal. So 2 minus 1, we said difference is 2. And now the borrow out of this subtraction at this bit position is 1. So we put in borrow in here. Now 0 minus 0 minus 1, again you have difference 1. Borrow out at this bit position is 1, which becomes borrow in here. So we now see 1 minus 1 minus 1. 1 minus 1 is 0, but 0 minus 1, the difference will be 1. Borrow out will be 1, which becomes borrow in here. So here 0 minus 0, 0. 0 minus 1, difference is 1. Borrow out is 1, which becomes borrow in here. Here again 1 minus 1, 0. 0 minus 1, difference out is 1. Borrow out is 1, which becomes borrow in to be 1 here. 1 minus 0, 1. 1 minus 1, difference is 0, but borrow out is 0, which becomes borrow in here, which is 0. So 1 minus 0 is 1, and 1 minus 0 is 1. So you see now at this bit position subtraction, we did not have any borrow from the next bit. So borrow out at this bit position subtraction is 0. And we see that we did not have any underflow of borrow. Positive number we got 233 minus 42 is 191, and to represent this number, since it is positive number, you don't need any extra bit to represent its sign. So magnitude of this positive number is given by 8 bits. So final number is 1 0 1 1 1 1 1 1. That is how you do bit by bit subtraction using this borrow method. So hope you are understanding so far. Let's move ahead. Multi-bit binary subtraction. Let's say you have this number 0011 and in decimal it is number 3 actually. Number A, 4 bits. Let's say you have numbers B, which is 0101. It is in decimal number 5. You want to do subtraction of 3 and 5. So you want to subtract decimal 5 from decimal 3. Of course, decimal 3 is smaller than decimal 5, or in other words, 5 is greater than 3. So how would you do the subtraction of B from A bit by bit? That is how we'll see. So what you see here, 4 bits of A and 4 bits of B. We'll start with the LSB of each. We'll write the LSB of A and B, which is 1, 1. So here you see 1, 1. 1 minus 1. The difference is 0. And of course, there is no borrowing in at this bit position of the subtraction. Therefore, for the next bit of subtraction where A is 1, B is 0, borrow in here is 0 because you did not borrow. So here is the bit position of A is 1, 0. That's what we wrote here, 1, 0. And the borrowing is 0. So 1 minus 0 minus 0. The difference is 1. Of course, you did not borrow anything from the next bit. So next bits of A are 0 and 1. That's what we will write here, 0 and 1. And the borrowing again, 0. How do we do this subtraction? 0 minus 1 minus 0. Of course, the 1 is great. You cannot do 0 minus 0 and then minus 1. No, go by sequence. 0 minus 1 minus 0. Of course, 1 is greater than 0. So difference here is 1 because this 0 will have to borrow 1 from its next disposition. This in binary, then this number is 1, 0. In decimal, as if it is number 2. And we will read as if we are subtracting 1 from 2. So 2 minus 1 will be 1. Or in binary, 1, 0 minus 1 will be 1. Of course, now the borrow out from this bit position is 1, which becomes borrow in here. So we'll write here borrow in. The final bits MSBs of A and B, 0, 0. And final subtraction at this bit position we'll see 0 minus 0 minus 1. Again, you have to borrow 1 from the next position. If there is any bit to borrow it out, there is no bit here, but the difference therefore will be written as 1 and the borrow out will be 1 and it will be represented and written as it just to indicate sign. So remember the difference of this subtraction is 1 1 1 0, which is representing the magnitude of the number 2, but final bit, that is the 5th bit, is put up right here. So total bits in the number is 1 1 1 1 0. 1 1 1 1 0. This is representing minus 2 in decimal. So 1 is showing it's a negative number, showing a sign. It is a signed binary number, which is number 2. So that's all. So hope you found this small module, tutorialistic model of multi-bit binary subtraction using borrow method, which is a traditional method of borrowing out of subtraction bit by bit. There are two ways of interpretation we've seen here. So hope you found this useful. If you did so, share it with others for wider reach. Stay tuned for more engaging content like this. Till then, wish you happy learning.